Hello, calculus students. This video contains the solutions for step-by-step problems 28 and 30. The first two from your current assignment. So, I am Mr. McGrath. Alright, this looks like a rectilinear motion problem. We've got a particle moving along the x-axis, so that for times greater than 0, its velocity is given by this function. Write an expression for the acceleration of the particle. Well, acceleration is the derivative of velocity, so let's see, we need the derivative of this. This is a product 2t excuse me, times natural log t. So the derivative of the first is 2 times the second plus the first times the derivative of the second minus 1. And I'll simplify that a little bit. That's 2 natural log t. 2t times 1 over t is 2, minus 1 is 1. So there's our expression for the acceleration. Part B, what are the values of t for which the particle is moving to the right? And justify your answer. Well, see, if we're moving along an x-axis, since on an x-axis this is the positive direction and this is negative, moving to the right means moving toward positive, in other words, having a positive velocity. Positive velocity means going this way, negative velocity means going this way. So I need to find, here's my velocity, right? I want to find where it's positive and where it's negative. So just as if we were trying to find increasing, decreasing, I'm going to set it equal to 0 and then I'll make a little number line. So if I want to know where it's moving to the right, I need to know when it's positive and negative, and to find the places where it switches, I set it equal to 0. So let's see, we can factor a t out of that. 2 natural log t minus 1. So this could be 0, or this could be 0. 2 natural log t minus 1 equals 0. And that, let's see, that would be natural log t is equal to add 1 divided by 2, 1/2, and that's the same as t is equal to, that would be e to the 1/2, right? So it looks like at time 0 and at time e to the 1/2. Now, I'm only interested in times greater than 0, so that's like, I don't actually have to check on the other side of that. And then e to the 1/2, whatever that is, it's the square root of e. So whatever the square root of e is, it's bigger than 1, right? Because this is like square root of e is like 3-ish, so it's about the square root of 3 in between 1 and 2. So I could check 1 here and see if this is positive or negative. So if I plug 1 in, that will be positive, and this would be, the natural log of 1 is 0 minus 1, so that would be negative. And sorry, I made these, let me get rid of those. Those were from the point I was making before. And then something bigger than e to the 1/2, like e, is bigger than the square root of e. So if I plug e in here, that would be positive. The natural log of e is 1, so that would be 2 minus 1, so that's positive. So when's it moving to the right? For what values of t? It's moving to the right when t is greater than e to the 1/2. And you could write that in interval notation if you wanted. You could write it as e to the 1/2. I could write it like that. That would be fine too. Alrighty. Is the particle speeding up or slowing down at t equals 1? Well, we already know that at t equals 1, the velocity is negative, right? We just did that part of our analysis here. And we've got our acceleration here, t equals 1. The acceleration would be plugging 1 in here. That's 2 times the natural log of 1 plus 1. The natural log of 1 is 0, so that's equal to 1. And so that's positive. So I've got negative acceleration, positive, say that again, negative velocity, positive acceleration. They're fighting against each other, so that means we are slowing down. Because velocity is less than 0 and acceleration is greater than 0. If these are fighting against each other, you're slowing down. If they're both positive or both negative, then you're speeding up. Alright, find the absolute minimum velocity of the particle and show the analysis that leads to our conclusion. If you want minimum of whatever, maximum or minimum of whatever, it means we have to take the derivative of this. So the minimum velocity happens when the derivative of this is 0. So I need to find the derivative of the velocity and set it equal to 0. See if we can find a minimum. Okay, again, if you want minimum of anything, you need to take the derivative of that thing, whatever this is. So remember in the last round of stuff we had a problem where you had to do minimum slope. That meant take the derivative of the slope, which again was a second derivative. So we want to take the derivative of velocity, which is acceleration, and set that equal to 0. And I have the acceleration up here, right? It's 2 times the natural log of t plus 1. So 2 natural log of t plus 1 equals 0. So natural log of t is equal to negative 1/2. So t would be e to the negative 1/2. And it just remains to show that this is, in fact, a minimum. So here's e to the negative 1/2. That's 1 over the square root of e. And the square root of e is, like maybe 1.5-ish, something like that. Or no, excuse me, I'm sorry, like 2/3-ish. It's 1 over 1.5, so about 2/3. So we need to find number below that, number above that. So I think I'll try 0 here. Oh, but we can't do that because it's not in the domain of this function. So we have to take things that are very close to 0. Well, as we approach 0, this approaches negative infinity, right? So negative infinity times 2 plus that's definitely negative. Right? Remember what the natural log function looks like. It looks like this, right? It plunges down to infinity as you get closer to 0. And then above, like if we pick a point like 1, for example, then the natural log of 1 is 0. 2 times 0 plus 1, that gives me a positive. So we want the absolute minimum velocity. Well, here you go. It's decreasing, increasing. So the absolute minimum happens at the 1 over the square root of e. Okay. In the Angry Birds game, the green bird, also known as the boomerang bird, can change directions. Suppose the green bird is catapulted along the x-axis, such that its position is given by this. Find an expression for the velocity of the bird. Well, this is position, so velocity is the derivative of that. So velocity is, let's see, the derivative of 4 times cosine of something is negative 4 times the sine of whatever, pi t squared, times the derivative of what's inside, which would be 2 pi t, right? Pi is just a number. And the derivative of 1 is 0. Okay, so there's my expression for velocity. I suppose you could simplify, bring that out to the front. There would be what? Negative 8 pi pi t times the sine of pi t squared. All right, for what values of t is the bird moving to the left? Well, that would be when the velocity is negative, right? Moving to the left means having a negative velocity. So I think I need to take my velocity and set it equal to 0 and then play the number line game. And I'm only looking in between 0 and the square root of 3/2. So let's see. We want our velocity, which is negative 8 pi t times the sine of pi t squared equal to 0. So what makes this equal to 0? Well, that's just 0. And what makes the sine of pi t squared equal to 0? Well, the sine of pi t squared, what angle can you take the sine of and get 0? Well, the sine of 0 is 0, and the sine of pi is 0, and the sine of 2 pi is 0, and so on. So I think t squared would have to be equal to 0 or 1 or 2 or so on and so on. So t squared could be equal to 0, 1, 2, so we get any multiple of pi here. And now, so the square roots of those, again, we're only looking, these values only positives, so 0 would work. The square root of 1, that is less than that. The square root of 2 is bigger than the square root of 1.5. So I think we're just looking at those two values here. So t equals 0 and t equals 1 are where the velocity changes direction. Now we need to set up the number line. 0, 1, and then we're maxing out at the square root of 3/2, so we need to check these. The trick here, I suppose, would be to pick values that make this fairly easy to evaluate, right? So any positive numbers, this, since t is only in positive numbers, this part's always going to be negative, right? Negative 8 times pi times t's are all positive in this range, so that's going to be negative. So then I need sine of pi times t squared. So I could pick something like, let's see, what would be a nice thing? Do the sine of, I guess, like the square root of 1/6, right? That would be in here. Why am I picking that weird number? Because when you square it, you get 1/6, and that would be like sine of pi over 6, which is positive, times a negative. So I think these are going to be negative in here. Again, you can pick something like pi over 6. I think we're talking about like the first bump of the sine curve here anyway. And then after here, we have like, let's see, what could we pick in between 1 and the square root of 3 over 2? I think we could pick something like something bigger than 1, like, I'm trying to think of something that's squared that would give us, not the square root of 3 over 2, but the square root of how about the square root of 5 over 4? Right? Because when you square that, you get 5/4, and that would give you 5 pi over 4, and that would give you a negative sign value, and then negative times negative. So sure enough, it changes there. A little tricky to pick those values. So where is it moving to the left? I think it's moving to the left in between 0 and 1. Right? That's when we have negative velocities. All right. Is the bird slowing down, speeding up, or neither at the square root of 3 over 2? Show the analysis that leads to your conclusion. So let's see. That's checking the signs of velocity and acceleration. So my velocity at the square root of 3 over 2 is equal to negative 8 pi times the square root of 3 over 2 times the sine of pi times the square root of 3 over 2 squared is 3/4, right? And the sine of 3 pi over 4, that's the y-coordinate here, that would be positive. So this is negative times positive, positive, positive. So that's all. It's going to be negative. All we care about is the sign, right? Acceleration. Ooh, did we find? We didn't find an acceleration function yet. All right, that's the derivative of this thing. So I'll treat this like it's the first and this like it's the second and do the product rule. So acceleration, derivative of the first, negative 8 pi times the second, sine of pi t squared, plus the first times the derivative of the second, and then chain rule on that, times the derivative of what's inside, which would be 2 pi t. Okay, that was fun. Now, we want to know what is the acceleration, what is the sign of it at the square root of 3 over 2. And I have something plus something, so I think I better keep track of what these values are. It's not all a product, so it's a little trickier to figure out if it's positive or negative. Let's see if we can do it. Got negative 8 pi times the sine. Remember, we just did this part. That's t squared is 3/4. The sine of 3 pi over 4 is square root of 2 over 2. Plus, or minus, I guess, negative 8 pi times t, square root of 3 over 2, times the cosine of 3 pi over 4, which is negative square root of 2 over 2, times 2 pi times t. Well, let's see. That's negative and this is positive. So I think we need to figure out which is bigger. And I think I can see it. See what you think. I think this is like negative 8 pi times the square root of 2 over 2. And then this is going to be negative times negative is positive. It's like 16 pi squared, which is also already quite a bit bigger than this. And then I have the square root of 3 over 2 times the square root of 3 over 2, which is 3/4 times square root of 2 over 2. So I think clearly this is bigger, right? That this is winning, because here I've got negative 8 pi square root of 2 over 2, and then I've got an 8 pi and a square root of 2 over 2 here, and then just more stuff that would make it bigger. 3/4 makes it a little bit smaller, but the extra 8 pi in here, certainly this is greater than 0. So I've got negative velocity, positive acceleration, so this is, once again, slowing down. And there's the analysis. It was a little trickier than the last one. How far does the bird travel by the time it reaches its absolute minimum value on the x-axis? So we want, I think I'm not really crazy about the wording here. I think it should be like minimum position, because it's not really reaching a value. I think that's a little misleading. But this is talking about position. So if we want to find a minimum position, we need to take the derivative of position and set it equal to 0. And I think we've already done that, right? If here, looking back at B, our bird was moving to the left and then to the right after that. So its minimum position would have been at time 1, right? So, and we want to know how far does the bird travel by the time it reaches its minimum value. I think that would be how far does it travel? That's between time 0 and time 1. It starts here, time 0, and then goes backwards to time 1. So we want position, that's our displacement from 1 to 0, right? Like y2 minus y1. Let's see if we can do that. So that's 4 times the cosine of pi times 1 squared minus 1. That's the position at 1. Minus 4 times the cosine of 0 minus 1. Okay. Cosine of pi is -1, so that's -4 minus 1, and then minus the cosine of 0 is 1, 4 minus 1. And so let's see, what is this? -5 minus 3, -8. So its displacement from time 0 to time 1 is -8. And they said, how far does it travel? So it travels 8 units to the left. Oops, there, sorry, we lost you at the bottom there. It travels 8 units to the left. Its displacement would be -8, but if somebody asks a question, how far, you would not answer with a negative number, right? You would just say 8 miles, 8 meters, 8 feet, whatever, or 8 units, and then you could say to the left. Okay.